How would you like to market energy-efficient and high-performance structures while saving installation time and cost on your next project? Matt Belcher is here to tell us how employing SIPs for your next building envelope positions the project to meet and surpass both current and future energy codes while promoting interior comfort and health at an affordable price. Now, if you're not sure who Matt is, here's a little bit more about his background. Matt Belcher is an experienced and nationally recognized builder, author, trainer, and consultant on the business of high-performance buildings and development. He has been actively involved in the construction industry for over 3 decades, including 6 years as a top building codes official in the St. Louis region. He has served on ICC code development committees, including the Energy and Water Committee of the International Green Construction Code and the IECC's Residential Energy Code Committee. Matt is director of the High Performance Buildings Research Center, which is part of the Midwest Energy Efficiency Research Consortium at the University of Missouri-Columbia. Matt resides on the board of directors of both and NHB. He serves as the chairman of NHB's Green Building and Energy Subcommittee and also serves on NHB's Building Codes and Standards Subcommittee. Finally, he serves on the Technology Committee with the Brussels, Belgium-based Active House Alliance. Now, I hope that during the course of today's presentation, you'll submit questions for our guest. To do so, you're going to use that question box that's over probably on the right side of your screen. I'm going to review those questions and pose them to Matt during the Q&A time that we've set aside near the end of the webcast. Matt, take it away.
Thank you very much, Mike. Thanks to everybody at Green Builder Media and all the folks at SEPA, too, with all their help putting everything together. And especially thank you to everybody listening in today or on a future recorded version of this session. Thank you very much for taking time out of your, I know, busy days to participate in this discussion about structural insulated panels. And hopefully some of the information will be very relevant to you on how you can apply this in a practical method, not only for a construction and design standpoint, but from a business standpoint too. So we will jump right into it. Things we're going to talk about today is kind of what's driving the market, especially today with energy codes and where that's all come to be. It's been part of my professional career for, I hate to tell you how many years, but as Mike said, over 3 decades. And also how you comply with current, not only current, but the upcoming markets and codes. Of course, building to above code programs, which we've done for years now, above code meaning some of the higher certification programs, and how that actually helps us be a little bit less affected in codes, since we're already building above those levels. We're going to talk about the building envelope itself, which obviously SIPS is the key element in, and how we deal with the elements we're trying to address with the building envelope. One thing that is usually not a high point of discussion, although it absolutely should be in every application, is the interior comfort and health, or in other terms, what we're trapping our clients in the building with. Of course, we'll address remodeling because that is an already big and rapidly expanding, growing market. And then how we market these, how, really the business application for structural insulated panels and the type of construction we do. So real quick, a quick background of what's driving the energy economy right now and what is having the largest impact on even building codes and some of the regulatory items that are out there. And of course, that is energy. When I was a building official way back in the last century, back in the mid-1980s, after our last energy crisis of the late 70s, the Model Energy Code was first introduced, and it was really trying to make buildings more energy efficient simply by making them tighter. And of course, as all of you that may be from my era remember, we caused all kinds of problems with buildings, with mold, moisture issues, indoor air quality problems, both in the commercial and the residential sector. I did a white paper for my then boss at St. Louis County on a new phenomenon called sick building syndrome in commercial buildings, and obviously it evolved over into the residential side. So that made us look a little bit more at what we were trying to do and addressing issues with buildings while making them energy efficient. In Austin, Texas, they started a green building program, and it really became the granddaddy, if you will, of what is now EPA's Energy Star program. And that was really driven by Austin Power and Light. They were looking at a tremendous population growth in the Austin area, and they didn't have the capacity or really the desire to expand their generating capacity. So they started addressing the energy efficiency side of things, the conservation side, and worked with the industry down there, the building industry, both commercial and residential, and came up with a green building program. As I said, was the basis what is now Energy Star. So as you can see on the slide here, Energy Star was launched in '92 for appliances. '95 it was launched for homes, and they are typically, I'm sorry, Energy Star is typically about 15% above what the current code is. That's kind of their modus operandi. They want to try to drive technology into the market by staying ahead of the current building codes and setting a little bit higher bar. And of course, then you have programs like the Building America program, the Builders Challenge, and now called the Challenge Home program, which is 30% more efficient than the current codes, and they're really reaching out trying to drive higher technology. And of course, Energy Star is now a partnership between DOE and EPA, and I would venture to guess that a lot of us on this call are stakeholders of some sort in that process. This was a slide that was put out a few years ago, but it really gives a good indication of where specifically the energy code has come from and is going. This is published by DOE. You can see the trajectory of code changes starting in 2006, and currently we're on the 2015 stage. The up to 2012 were fairly accurate. Beyond 2009, they were somewhat projected when the slide was produced. The jump to 2015 wasn't as dramatic because the temper of this trajectory when 2012 was issued, it really didn't get adopted by a lot of entities, so that really slowed down the upward progression of codes. And also, as you see on this slide, the 2015 code was actually the first time they split, since the energy code was published, they split the residential code out of the energy code, making it freestanding. Obviously, it's also Chapter 11 of the residential code is also the IECC-R, the residential version. It also incorporated, the 2015 version also incorporated the HERS index as an equivalent for residential, which was good because it is some sort of standard that was out there, although at the time is somewhat of a proprietary standard. But it gives builders, and it did myself as I was working in Energy Star programs, gives us some good metrics to put these homes together in a holistic basis, if you will, and gives you values for equipment and advanced components such as SIPS panels. So these are just some of the other changes that were incorporated into those. And as you see here at the bottom, the 2018 Energy Code review has already begun. We've already had a number of conference calls about it. The Energy Code meeting will be in April, and the whole process starts over again. So we're already looking at proposals to modify the code going into 2018. But you're also seeing it incorporate some of the technologies that are out there. Of course, structural panels have been part of the code, the residential code, for a number of years now. So they have their own method. And as I mentioned earlier, also some of the federal act this year, the Clean Power Plan rule. It shouldn't be plants; it should be plan rule. But that was enacted really from the current administration, from the White House level, but it's enforced and promulgated by EPA, and they're looking at energy efficiency programs, increase codes, try to create more local programs, and engage utilities and that sort of thing. That was launched in September. It's been challenged in courts. Something will come out of it, but it's still pretty much up in the air where that actual rule is going to land as it impacts our industry. And there's also a comprehensive energy bill that's going through Congress. So far, it's fairly bipartisan, but we are heading into a fairly heated election year, so it'd be interesting to see where it ends up by the end of this congressional session. And just to quickly point out, that's the $2,000 tax credit for builders building homes. That is going to expire. It will probably be reinstituted next year, but it will be done retroactively instead of, unfortunately, is moving forward. So it's always a reach back to try to keep up with those rules. So that's just a quick update of codes and regulatory issues that are impacting what we do. And very quickly, I mentioned earlier the above code program. Obviously, NHB has the National Green Building Standard, ANSI ICC 700. I mentioned Energy Star. EPA also has their indoor air quality program. They have the Water Sense program for water efficient fixtures and homes. I mentioned the Building America program, the Builders Challenge, now called the Challenge Home program. LEED for Homes is another metric that we have built to. The Active House, Mike mentioned that in the introduction. Active House is a European green standard that they have been developing, a holistic program that works on energy conservation, water conservation, and occupant health. They developed that standard a few years ago as a specification and had set out to build some prototype homes, of which we were fortunate to build one in the St. Louis area. And it's a good holistic standard. It's quite similar to a lot of the others, and a lot of you that have built to these levels or hopefully will build to these levels, you'll find that a lot of the metrics that are in these are overlapping or quite similar. So once you build to one, it's easy to certify to a number of them. And we do that. We'll build to the National Green Building Standard, but we also certify to Energy Star, the indoor air program, because that's for the occupant health, and the Water Sense program because it helps our marketing. It's just a good way to brand not only your home that you're building or your building that you're building, but also brand yourself too. I had mentioned also that SIPs are in the International Residential Code, but they're also discussed in the National Green Building Standard. These are the sections that directly apply to structural insulated panels and where you can claim points in that program. Obviously, this presentation's you'll be able to go back and capture this information also. But this is just an example of where SIPs directly are applicable to and above code programs such as the National Green Building Standard. You can see they apply for not only energy but also resource efficiency and indoor environmental quality because of the components they're made of, the way they're manufactured, the energy efficiency envelope that they create, and at the end of the day, how they help you manage the indoor environmental quality so much better. The first thing we do in our projects, and this is any project we do, residential, commercial, or remodel, you have to have a knowledgeable team. The biggest barrier in McGraw-Hill Construction, which is the kind of the top statistician of the building industry, has now changed their name to Dodge, but the biggest barrier they've cited to the expansion of these high-quality building programs or above code programs is simply education and knowledge of the people that are working in the industry. And that includes everybody on this list. Obviously, the builders, design professionals, the building and suppliers and subcontractors, and I'm proud to be affiliated with the University of Missouri, where we're actually working to address that part of the equation for the industry, and is working on training. SEPA itself, Structural Insulated Panel Association, has its own training program focused on proper methods, use, assembly, and the background for structural insulated panels. At the very end of this presentation, I'll show you a link for that training. But this is key to putting these homes together. We get all these folks together when we start planning a project, and we look at the most efficient and effective way to use materials, the best way to address issues we're trying to address with homes to achieve the highest levels we can. And we'll sit around the conference room table at the architect's office or someone's office, get our mechanical trades, our carpenter in there, and we literally sit there and virtually build that house or that building there at the conference room table and solve some of those issues that typically happen out in the field, where it gets expensive while you're standing out there with the different trades trying to solve a problem. We, like I said, we virtually build that building at the conference room table, so by the time we get to the field, we've already built that once. So it makes, you're still going to have problems. That's the nature of the beast, but it certainly does eliminate those and saves a tremendous amount of time. And of course, time is money in this industry too. Certifications, National Association of Home Builders has the Certified Green Professional designations you see there. Obviously, LEED has the LEED AP program. SEPA with their training, once you go through that training, you get a certificate. And I've found as on the builder side, as a consumer of materials and labor, when I'm dealing with suppliers or subcontractors or trades or anybody in my circle I operate in, if they've gone through this training and understand what I'm talking about, what I'm trying to get at, first of all, it makes my life much easier, makes the process easier, and frankly, from a business standpoint, a pure business standpoint, it really makes me feel better about my liability expectations in that project, because I know these guys are going to understand the simple building science behind these projects, the why we're documenting things, and why we have these metrics, whether it's Energy Star or whatever program checklist that we're following, why we're doing these things, and the third-party inspection side of it also that goes with that. It's a tremendous benefit just from a business operations standpoint. Of course, when we're talking about structural insulated panels, we're talking about a panelized construction process with the progression of codes, not only the energy code, but the progression of more resilient design and construction in the building codes, the residential code and the building code, and some of the other rules and regulations that are out there, and the cost of raw materials to build with. You're seeing a much bigger impact into the market for panelized or systemic construction practices. It's very cost effective on economies of scale, especially on the production side. It is much more cost effective. The quality control is higher. You're usually able to get in your building enclosed in a much quicker fashion. With structural insulated panels, they're put together in a atmospherically or climate controlled building typically. So the assembly is done in a much less hostile environment sometimes than a job site might be. So the end product arrives at the job site ready to be put together, and it just makes for a lot better assembly process, and it performs better not only through the construction process, but then again through the life of that house. So you're seeing a lot more of this type of systemic construction, and frankly, just because of the materials, everything we build a home with is either mined or grown. Whether it's a metal that's mined or a wood or other fiber sourced material or the chemical makeup of SIPs with its components, or it's a recycled product. And you see a lot of that. You see on that top picture that structural insulated panel sitting there with OSB sheathing, the structural elements to it, and even the foam insulation, which is also part of that structure. And all of that material is made out of recycled content, and or it itself can be recycled when it reaches the end of its useful life. So just the cost to produce new as opposed to the sustainable way of using the systemic construction is just rapidly growing in the industry, and it has been for some time. You're also looking at the envelope performance requirements, again, not only for energy, but for the durability of these homes, with the increases in wind speed design and items like that are, with all the different natural disasters that we have had over the past few decades, especially, have really worked their way into the building codes to pull these buildings together and make them not only tighter to the from the elements so they perform better thermally, but also tighter construction as far as resiliency when it comes to wind loads and things like that. We're in the St. Louis area, and so we're right in the middle of Tornado Alley. We're also in the New Madrid seismic zone, and so we're in essence building bunkers that look like homes here. So it's cost effective to do as long as we get our process down. We can manage it very well. Obviously, the end product for that client is much better that way too. This picture you see of this house on the slide was actually a Green Builder Media, Green Builder Magazine's vision home back in 2007. This was a LEED Platinum home that was put together. You can see Intercept's name on the building wrap proudly displayed, so they were part of that project also. But this was a client that was an architect and worked on her own design, and the flexibility that we had using structural insulated panels to take her concept and make it real was huge. So they still live in this house. They were a young family. Their kids are all just about to get to high school now, so and they're very happy. It still performs very well. It was not only from a heating and cooling standpoint, the adaptability, we were able to design this to incorporate future solar, which they have now incorporated into this home to further reduce their energy bills. She also charted their visits to the pediatrician with their kids based on the same visits, the number of visits and types of visits they had when they lived in the home that they had moved out of. And they had seen improvements in that. Now, we don't have enough of a study or enough data to make any type of claims, but they certainly feel that their benefit to move into a healthier home has certainly helped them out. So you focus on all those items. You start with a good building and good building envelope. It's much easier to take care of all the other items when you get to the inside of the house. Nice thing was, with the speed of construction, we were up under roof with this house in just about a week. And once it's up, of course, it's already insulated. So all we did was close off the openings. Picture was taken in January of that year, in 2007, and it didn't take hardly any heat at all to keep that house warm. The guys finished framing out the inside, working in T-shirts, and that's the finished product from virtually the same view. So she did a great job with her design, made it easy to build, and like I said, they're very happy in there. So it met and frankly well exceeded the envelope performance requirements we needed, and we ended up we were just hoping to get a LEED certified home, and we thought, filling out our score sheets, we may be high silver, maybe even in the gold, and USGBC came back and said, no, you guys are platinum. And we were skeptical at first because we didn't want to say we were something we weren't, but they insisted, and we were proud to stake that claim. So, and like I said, the most important thing is the folks that live there are very happy and healthy because of it. As I mentioned too, the envelope performance allows us to really focus on what we put inside that house. This little bitty furnace here is all we need. This variable speed. It's a gas furnace. We put this small. It was a 3-ton unit, variable speed unit in here. So it was very cost effective to do. It all design, as I showed in a previous slide. When you have a good design, it is much easier to make that house perform. So if you include these thoughts in the design process, you end up with a much better end result. It all starts with that envelope. Then we can come in with a very cost-effective but very high-efficient HVAC system. It's critical, it's size for that home or the building. So many times you see homes that are have typical mechanical systems put into them, and they underperform. They come on and at a normal high speed, and they'll pressurize that home and get it up to temperature, and then shut off, and it cools back down. So it's much harder to find that comfortable spot than when you have these types of high performance equipment. And they'll maintain. They last longer because they don't work as hard as their traditional counterparts, and they'll run on lower speed motors. They don't use as much energy, but they do turn the air over in the house more frequently and draw it across those filters more often. So that also helps with the indoor air quality. And we also, through good design, were able to design a water system that was very efficient in here also. That one Renai tankless water heater served the entire house, family of 4. Just the kitchen, bedrooms, baths were all aligned in the central corridor of the house, and so we served those all with that one water heater. So it's done very well over the years. So we'll talk a little bit about simple building science and why it's so important to focus on these and the ramifications if you don't, and why SIPs are such an easy answer to dealing with these situations. Obviously, water is the builder's worst enemy, and that's water, whether it's bulk water in the form of rain or water vapor with air movement. When it's like today here, it's 50% relative humidity or so. Well, that means that air's about half water with the vapor component that's in there. So when that air moves through those walls, it's bringing that moisture in with it. So we just need to make sure that we use a good envelope to mitigate that airflow, and then we can deal with the trace amounts of vapor that may be in or outside of those walls. Obviously, we want them to be resilient for the elements that are outside, whether it's seismic resilience for earthquake zones like we're in, or our seismic zones we're in, or in high wind zones. We're around the coast with the Gulf areas, the coast, or here in Tornado Alley, or anywhere, it seems, where you may have wind issues. And, of course, the thermal performance is huge. And just the moisture transfer and the thermal transfer that you have, you see on the left-hand side is a snapshot of a typical, it's really to demonstrate the vapor permeance of a typical frame, fiberglass insulated with a brick veneer wall, which is the bulk of the homes built probably in the Midwest and beyond. But you see the concerns you have with air and moisture transfer in that wall configuration. You have the airspace behind the brick wall that will hopefully allow for drainage down the backside of that masonry wall and airflow to dry that cavity out. You also have moisture drive. If you get that brick wet and the sun shines on it, that heating effect will drive that moisture through that brick. Then you got to worry about the transfer of air. If you have moist air behind that brick veneer and a lesser ability for that wall cavity to resist air transfer, well, that air is going to transfer into that space, carrying that moisture with it. If it's a good, hot, humid day outside, like we have here 4 or 5 months out of the year, and you're cooling on the inside, you may create a cool space on the inside of that drywall where that vapor-laden air could condense. So, and then you have moisture inside your wall. So you're just, it's not that you may have mold issues, you will have mold issues if you don't do that configuration properly. Or you can see a cross-section on the right-hand picture of a structural insulated panel. You don't have those wall cavity issues with panels like that. They are highly resistant to air transfer, and along with the structural capability and the continuous insulation through them. Also, you can see in this particular window opening right here how we have a break, a thermal break at each side of the window where that foam comes straight through to it, and it travels down that wall. At the bottom of that window opening, you see a little hole there. That's a courtesy hole, so you can pull electric wires through there, and there'll be outlet locations already cut into these panels, or they're flexible enough that you can also cut them into the panels if you need to relocate or add a new outlet. And you see the blue lines that are laid out on those panels. Those are vertical and horizontal chases with those courtesy holes in them for electric to be run through those wall panels. So it takes very little work with our electrician to get them used to working with these panels. The education curve was very rapid on these first installations we've done with them. Same with the carpenters in the assembly. They were actually anxious to do this so they could learn this technique, and now they're one of the few subcontractors in the industry in our area that are well experienced in building structural insulated panels. So as these use of these panels have grown in the market, their business has expanded almost exponentially, because they were, for a long time, were the only game in town. Obviously, their competition's taking notice, and they're getting their guys trained also, to the point that the carpenter, we're a union carpenter town, and the Carpenters Training Center have now incorporated SIP panel construction into their training. So, and that's a good thing for all of us, because it grows the market. You may have seen these slides before. They're from the guys that are really the true experts in our industry on these types of subjects from Building Science Corporation. And it's an example of moisture flow with the water vapor in the air when you have holes in your walls, or which happen in the construction process, or gaps, or the ability for that vapor-laden air to transfer through, either into or through that wall. And obviously, if you have a condensing surface, or the dew point is inside that wall, that's where that water gets trapped. And you can see it's fairly dramatic. It shows the amount of water that can travel through a small hole or gap in a wall, and why it's so important to make this construction as tight and as resilient as you can. So, and this shows here again that same slide, and then that same cross section of that structural panel where you have that dense foam as your wall cavity. So it is more resilient as far as air and moisture transfer goes too. It is a great way to mitigate those air and moisture transfer problems. And this is a quick description on how this sort of things work, and the resilient nature of these panels from a air and moisture transfer. Obviously, I think most of you hopefully heard about the PERM ratings of different building materials and how they're assembled, and obviously this is what controls the transfer of air and moisture through those materials. So this just shows the typical skin on a structural insulated panel is made out of OSB, or oriented strand board. And the reason that this is used so predominantly in construction right now, there's multiple reasons. It's the way that trees are harvested for use now also include a lot of hybrid trees, where we can create a tree that will grow to harvestable size in 7 or 8 years, where Mother Nature might take 24 years to grow a tree to that same size. So we can harvest it, make it more of a renewable resource. However, when you grow a tree to harvestable size in 7 years, you cut it and look at the end grain, and there's only 7 growth rings in there. So it is a less dense log. However, we can take that log now and grind it up and use all the components to it, compress it back together with a low VOC but high strength epoxy, and that's why you see a predominance of OSB, oriented strand boards, more engineered I-joists, and structural items too. It is a pretty effective way to do that. However, it also lends itself to be a good skin for these panels because the permeating performs so much better, especially over a period of time where it's exposed to a higher moisture level. And here in the St. Louis area, and I know a lot of areas around the Gulf Coast and different parts of the country, you're going to see relative humidity levels on the exterior of the building in the 60-70% easy, especially in the summertime. And then, of course, on the inside of the building, you may see humidity levels 50-60%, especially first thing in the morning, say when you everybody takes a shower and temporarily loads that house up with humidity, or that combined with cooking, say, may put higher humidity loads. So this just demonstrates the additional resiliency of structural insulated panels just because of the components that they're made up with. And of course, real quickly, we're talking about the major damage functions to a building. As I mentioned, water is the builder's worst enemy, whether it's liquid water in the form of rain, bulk water, capillary action where it may lay against a building component and get drawn into the building or off of through a concrete slab or concrete wall, say, through capillary action. Obviously, airborne water vapor, radiation and UV degradation we hadn't touched on, but the fact that when buildings are framed up and their materials are delivered on site and left out in the sun, it is amazing if you ever have the chance to take the building science course through EVA or through Building Science Corporation. They have some great demonstrations on UV degradation of building materials if you have them out in the sun for very long before they get enclosed. The cell damage for that, because the wood structure, wood framing is a cellulose material, and the cell structure damage it does to that, which degrades the structural capability of those elements, is pretty significant. So being able to get a building up quickly and enclose quickly is a big thing, a lot bigger than most people realize. And obviously the other damage functions, and this is true at my house too, between pests and especially people. I know myself and my wife would probably be the first to tell you I'm pretty hard on a building. So you know, to have them be resilient for all the environmental concerns and plus the normal use. You know, between woodpeckers and squirrels and whatever else may try to attack your house, and then it's just its everyday use between people and also pets, etc. So resiliency is a big thing, not only for the life of the building through the construction process and then the life of the building. And this is something that is a good subject that we address with the operation of buildings. When I had mentioned this earlier, when that HVAC system kicks on and it literally pressurizes the inside of that house, and of course we're building homes and buildings much tighter now than we have in the past, so it's even more of a pronounced event that happens in these houses. But you know, of course, the resilient nature of the construction of SIPS panels and that tight construction and the systemic nature in what they're put together, they're much more resilient. This not only doesn't happen just when the HVAC system kicks on, but it happens over the life of that building. So the internal pressures that are put on those buildings are significant, which is another argument also for a properly sized HVAC system. So again, the major protection systems in the house, they need to be systemic or systematic, comprehensive where they're continuous, using the best practices. I always talk about to builders, quality in building is like hustle in sports. You never look bad when you do it. And then also, addressing all of these items using 3 of the following methods: design, materials, and workmanship. The better the materials and workmanship, and then combined with good design, it's a win-win. Obviously, quality control is everything. A guy told me years ago, you don't get what you expect, you get what you inspect. So, testing for moisture issues before you cover them up, making sure you check your flashings. And this is one thing that the above code programs and those checklists and metrics help you with. They help you with that quality control program. And then obviously the final testing, the blower door testing, and commissioning if you want to get that building certified, which to me we do simply from a pure liability standpoint. It's a great sales tool, but also to have that third-party certification is a great liability protection tool. Very inexpensive to do. And we'll talk real quick about the ventilation and indoor air quality. Obviously, with a better building envelope and a good air sealing package, the proper HVAC design and equipment and installation, then the V in HVAC is obviously ventilation, and that is as important as the H in the AC, frankly. And you may add an energy recovery ventilator or a heat recovery ventilator to help with the moisture control and the heat transfer, not wasting your paid-for air, if you will, out of the house. It captures the heat out of the air you're exhausting, or tempers that warm air you're bringing in the summertime, cooling it a little bit. Makes that equipment perform even more efficiently. And again, it starts with that good building envelope, because you do that, you can put smaller, appropriately sized equipment in there, and it performs very well, and it lasts a lot longer too. And obviously, water heating design. 20% of an energy use in a building is for heating water, and anymore that's mainly for the master shower, because we're using Energy Star dishwashers and washing machines and such appliances. So water heating design is a big energy concern too. But again, through proper design, it's much easier to do. And of course, we're talking about healthy homes and buildings. This was as I mentioned when I was a code official back in the 80s, the indoor air quality issues that happen because of the way we tighten buildings up is just a hugely important part of the process that needs to be focused on throughout the design and construction process. But it's much easier to address today because of the better building components we have, such as structural panels, the lack of off-gassing because they don't have added formaldehyde to the components like they did back in the 80s. And just, the better building science that we have nowadays. We can build a much better building. We can build a much better building today than we could just 10 years ago because of the advancements in the building components that we have. And of course, as I said earlier, time is money. Being able to get things up enclosed and insulated in a short period of time is better, not only for the components and the end result of the house itself, but frankly, it just saves time. Instead of taking a month to stick frame something, we're up in a week. So that's always a good thing. And we're cost competitive too. And very quickly, I'll touch on remodeling. I'm going to get to some questions here too. If you have any, please feel free to type them in, and Michael make sure I get them. Remodeling is a big market, about to be very big market. It's been steadily growing over the last 6 or 7 years. Obviously, with 130 million almost housing units in the United States, new homes is just a small percentage. So 98.5% of all homes that are out there are 10 years old or older. So you know, it's a big opportunity out there, not only for the business side of things, but also to enhance our existing housing stock in this country, which is the bulk of the energy use in this country also, as far as buildings go. You know, when you talk to customers, this was a survey done by Eco Home Magazine. Energy savings is a must. Obviously, indoor air quality and things like that are also a high priority, but it's all part of that same package. We do remodeling. We'll go into a house, and we mainly do gut rehab type remodels. We don't do small jobs, but we'll go in and find where that house is as it sits. You know, that may help us develop the scope of the project. There may be parts of the building that are very well built and perform just fine. They don't need to be renovated, and in other times we find that need deep renovation. So we'll go in and establish that baseline, and then at the end of the day, we know what our results are and the improvements we made too. This was a home that we remodeled just a few years ago. It was built in the 50s. It was a young couple owned it. It was his grandparents' house. They had bought it out of the estate after Grandpa died and wanted to remodel it. We basically took the roof off it, put a second floor on. We used structural insulation panels to line the inside because we didn't want to change the architecture of the home. It was a fully masonry constructed home, so it had some pretty good resilience to it, but then you have the issues that masonry construction may have with vapor transfer and things like that. So SIPs were an easy answer to make this home perform. And you can see this was an email he sent me after in there. Obviously, they had the energy bills from when their grandpa lived there, so he was able to give us some apples to apples comparisons for what we had done for that house. We basically doubled the square footage of it and cut the energy use in half. We took a 4-ton forced air HVAC system, furnace and air conditioner out of there, and put a 4-ton geothermal system in. Same size system, only double the square footage of the house. Did a better job of the envelope. And this was the email he sent me. And they added a little bit of solar that they leased on the roof, and he ended up with about 3 times less energy uses with twice the square footage. So it was a cost-effective way to do this. They're in a great neighborhood. We can't overbuild and overbuild our competition. We have to. Competition kind of rules what we do. So we were able to do that cost competitively, and they're still very happy with it. So you know, talking about the business application, we're talking about buildings that may cost a slight bit more to build for a higher level of quality. However, the value of them are so much higher. So we really need to pay attention to how we spend that money when it comes from the budget. And this is results from a survey that McGraw-Hill Construction did a few years ago. You can see where the incremental cost to build these homes has decreased for builders over the past, really going on almost a decade. This was a period of about 6 years when they did this survey. And then you can see it's even lower for builders to do this. And the reason that is because it's their process. I was asked a lot if I build a high-performance home and not high-performance home, and I'd always jokingly tell them I don't because I'm not smart enough to do both. But frankly, what it is once you get your process down, that's what you do. You use the metrics that are lined out in the Energy Star checklist or the ICC 700, the National Green Building Standard, and you get your subcontractor up to speed on doing this, and it's just that is how your process goes. So the incremental cost is much lower the more of these you do. Obviously, using a systemic construction method helps that equation too. The marketing, as you can see, the impact on marketing has gone up significantly. That has a lot to do with more educated consumers, which is a good thing. And obviously, it's significant for firms that are dedicated to this sort of thing, because those are the go-to guys that consumers will look for. You'll hear a builder say, well, nobody's asking me for it. Well, that's probably because the people that are looking for it have already found the people that they want to do that home for. And those are the guys that are the ones that are focused on doing just that. And again, it comes down to cost. The client's budget is everything. Their bottom line is your bottom line. You can achieve it through a right-sized home, through better design. We can take a 2,500, 2,400 square foot home and make it feel like a 3,000 square foot home very easily, just through better design. And then focus on the important things to them, the comfort, durability, and resiliency. We have to be competitively priced. The competition sets our price. The only thing we can control is our cost, really. And we do that, obviously, as I showed you before, through our process. But then at the end of the day, also the energy savings, the reduced maintenance that are intrinsic to these better built homes is a cash savings, which amounts to equity for these clients. And if you look at a monthly payment in the form of a pie chart, obviously by far the biggest portion of that monthly payment is the cost of that house, the principal, interest, taxes, insurance. Then you look at the next bigger slice of that pie is energy, the maintenance, and obviously that's the part of the pie that we focus on. We can cut that part of the pie in half immediately using better products like structural insulated panels. So they're more durable, they've got much less energy use, and most every consumer lives on a monthly payment, so we can demonstrate to them by having a little bit more principal in that house, 2% more principal, we can save them 35, 40% and much better on the energy operation and maintenance side of the equation. So the trade-off is real. The numbers don't lie, and of course neither do the science. Obviously the appraiser is key to the whole financing proposition. They're the keystone of the avalanche to make it happen. So we require the lenders we use, because there's training out there now for appraisers to do the valuations on these types of homes. Their energy source have some sort of third-party certified. We require that lender use an appraiser that has that documented training for those, and we have come to realize that the homes we're doing, they usually qualify for about 10% higher appraisal in the construction loan than we have the contract for. We're still making money. That 10% is immediate equity for that homeowner. Usually you have a pretty happy client. The Appraisal Institute has come out with a green and energy efficient addendum. It's a HUD addendum for the appraisal. We use them on every job, whether the Appraisal Institute appraisers do the appraisal or not. We still use them. And this is a link to them. Again, this session's being recorded, so you'll be able to go back and get this link to, and feel free to use this lender specification. That's yours to use too. The more people that do this, the more it'll grow that market. And this is where structural insulated panels are applied. You can see this is a appraisal addendum we filled out for a structural insulated panel home, and how we indicated on this appraisal addendum. We fill this out ourselves and give it to you because we know what the house is built with, the sizes of the components and things like that, to technical data, and we give it to the appraiser. He obviously has to verify all this is correct, but it makes the whole process flow a lot easier. But this is how that applies on that appraisal. This particular home, structural insulated panel home, appraised for 20% above contract price in the construction loan. the client didn't have to bring a dime to close on the construction loan. He was 20% in already by virtue of the fact of what we were building that house with. So you just need to insist on that trained or qualified appraiser. If there's none in your market, get a hold of your local appraisers and get them going. The training is out there and it's available. Same way with the lenders. Just engage your lenders and work with them and talk about this with them because they want to make these loans. But what this does is keeps you from being comped against a short sale down the street. This makes them look at this house in a systemic fashion and gives you the value for that structural insulated panel envelope or that geothermal system. It costs a little more, but it's worth a little more. And this gets you closer to the true value of those sorts of things. So these are the clients here. They're groundbreaking. It was competitively priced. Comped in that neighborhood very well. And they've been in there 2 years now. I just talked to them the other day, and they're happy as can be. They have constant and actually a little bit better utility bills now because they have gotten used to operating that house, and they really know how to tweak it to make it operate even more efficiently than they first got in there. And of course, that extra value is just nothing but equity to them. So they go to sell that house. First of all, you see the little girl there. I told them, when she goes to college, that house will still be code compliant. It will not be obsolete because it will hold its value because we're building using above standard methods and above code processes to get there. So very quickly, some of the key takeaways from this, and at the end of the day, at the very bottom there, you see how the codes are contained. This is true for this 2018 edition of the codes. They're continuing to accelerate the envelope performance requirements, which makes SIPs even more attractive to builders like me because once you incorporate those into the plan, all those performance requirements are not only met, they're exceeded, and which means that they'll stay met for a long period of time. Obviously, the liability protection, investment performance, and the equity that's created by using better homes. Obviously, the home is probably the biggest investment that these folks will make, and why wouldn't it want to perform as good as any other investment, say in the stock market, might perform over 15 or 30 years, which is the life of the mortgage. So we'll wrap up here real quick. If there's questions, I'm happy to take some time to answer them. It's not a linear process like it used to be, where you go select a lot and the house plan and the cabinet colors and the paint colors and things. It's all integrated systems now, which is a much better product at the end of the day. It helps our industry because we're building better products. Affordability is key to sustainability. If it's not affordable, it's not affordable, but it also needs to be affordable for the life of that building. Most people buy a home, they don't even think about closing costs, much less what it costs to live there for the life of that building. Well, this is reining that part of the equation in. As I mentioned earlier, Structural Insulated Panels, SEPA Association, has SIP School, and there's the link to that, sipschool.org. It's a great training program. There's a lot of online training. Go to the SEPA website, sips.org, and there's a lot of great information on there and how to contact these folks to get engaged with this. My contact information is right there. Feel free to get a hold of me, and I'm happy to talk to you about it or be of help if I can. And of course, sips.org is the website for SEPA. And I'm happy to take any questions now if there are any. Mike, I'll kick it back over to you real quick.
All right, thanks, Matt. Yeah, we've got a number of questions, so I want to make sure to get right to those, but also don't want to discourage anybody. So if you do have questions based on what you've just listened to and seen, please make sure to use that question box over on the right side. I want to get right to it with Robert had a question about SIPs. Can they be used for an in-ground pressure-treated foundation system? I mean, you talked a lot about water vapor and how this SIPs can really help with that. What about for that application?
Good question, Robert, because I didn't cover that in this webinar. But that is an application for structural panels too. For years we put poured concrete foundations in and would insulate the foundation wall with foam insulation or whatever. Well, now there are SIPs panels that specifically address in-ground insulation. So you set the panels. It's the same process too. You excavate the hole, and not to belabor the point, but you can go to the SIP's website, and I believe there may even be photographs on there. But you can excavate the hole and set the panels, and then your foundation's in, and it's insulated in much less time. So it's a great proposition for foundations also. Not only foundations, but even short walls for crawl spaces. That way you have an insulated crawl space.
Steve has a number of questions. I want to get to some of his, certainly. He wanted to know, how do you get a design professional to specify SIPs instead of just the typical fiberglass or spray foam?
Well, another good question, because that's half the battle. We do a lot of outreach with our local residential architects on the home side, and then of course the commercial guy, and there's some that do both residential and commercial. But educating architects is a huge part of what we do with SEPA. It's a huge part of what we do here locally. It benefits us. And of course, SEPA has a lot of great information for architects right on their website. We can get details and information. And the nice thing about using structural insulated panels is most all of the manufacturers, they do their own engineering. So we'll take a draft set of house plans to the manufacturer, and they will do the engineering. They'll give you the quote, they'll do the engineering, and then supply the local architect with all that structural information, all that code compliance information that they need, so that local architect or design professional can incorporate that and then come up with a complete set of plans. Again, the SIPs are in the residential code and the building code, and of course the above code, ICC 700. So there's a lot of guiding document right there that's already in the code for design professionals to use. But every SIP supplier, all the ones we've used, provide that engineering that is needed for the design process. So it makes it a lot easier if you have an architect that's never used SIPs before, to incorporate in what they already do. And everyone we talk to that has not done it before are extremely interested in learning, because again, it gives them a whole new market that they can operate in also. It helps them out.
You mentioned learning, and Steve had another question in regards to education. He's saying that consumers and most builders, they think that just a stick-built wall with fiberglass insulation is the same as an R24 SIP wall. Matt, you and I know that's not the case, but how do you address this?
Well, it's education, as I said before. McGraw-Hill Construction even identified education not only for consumers, but even the building industry is the biggest hurdle we have for any type of high-performance building, much less just a SIPs building. But with structural insulated panels, it's quite easy. Again, the SEPA website has great information. I'll refer a client that's interested in SIPs to that website first of all to get information, and we literally sit down with them and explain to them not only the structural integrity benefits of structural insulated panels and the thermal benefits, but the nature of how they are. It's not just a stud wall with fiberglass insulation. You have a continuous insulation where that building is completely tied together from panel to panel and roof panels down to the wall panels, all the way down to the foundation, and the whole process, why it is a superior way to build buildings. I always tell him if there was a fourth little pig, he would have built his home out of SIP panels.
And I think too, something to add to that is that ACH 50 levels are something that's often debated in the energy codes.
Yeah.
But it seems like SIPs can achieve tightness levels that is greatly going to reduce code compliance concerns from builders.
They do, and that's a great point. I mean, they just do by nature of what they are. As I mentioned earlier, we're reviewing the 2018 code changes now, and there's more of an effort with. And I won't get technical on it, but there's just much more focus on the HERS rating and the air changes per hour, and getting those buildings tighter and tighter and tighter. And it's all focused on the envelope. There's no reference at all to equipment or offsets or anything, other than making sure it's ventilated properly. But addressing the envelope issues, it's with a structural insulated panel, it's done. It's inherent. It doesn't only meet the code, but it exceeds the code. We'll locally here, we're going in the St. Louis metro area, we're going to the 2015 code, and they were looking to go from 5 air changes per hour down to 3, and 3 H50. And that home I showed you with that young couple, we did that completely last structural incidents. We were at 1.5. It's just not only did it meet current code, but it met the new code, and it will meet the forthcoming codes for a long time to come. So, in that building envelope, just like we tell them, that's the part of the house that's going to be there longer than anything. That high efficient furnace we put in there after 15, 20 years is going to be replaced most likely or most certainly with a higher performing furnace, because that's what will be on the market then. So, we tell them when you're making the investment, you got to get the best bang for the buck, and the building envelope is where you start. Obviously, in the 80s and 90s into the early 2000s, we kind of got away from that because people felt if you can't see it, I don't want to spend money on it. But then they have to live with that decision in the form of higher monthly payments through utilities and operation and maintenance. Then it puts your feet on the ground real quick.
Larry had a question. A lot of your pictures showed SIPs using OSB. Have you built with SIPs that use galvanized aluminum? And if you have, do you have an opinion on that?
Yeah, we've used structural insulated panels without what they are is they're light steel framed structural insulated panel. They have no skin on them. They have basically a steel framing, and they're wonderful. I mean, they operate terrifically. They're very lightweight, so they're easy to work with. Thermally, they perform very well. It's just a great. It's kind of like a different, better mousetrap, if you will. Just a different version of SIP. So, and you can, they've used them. I know to create safe rooms with. Buddy of mine's a distributor for them, and they take and put a galvanized metal skin on them, and he's actually taken them down to I think it's Texas A&M has that stud gun that they use for testing for ANSI or for FEMA rather, and I have created safe rooms out of those, which are nice because if they're lightweight, you can carry them into a basement or into a house and create a safe room inside that house. So yeah, it's a great product. Great product.
Steve was wondering about, you talked earlier about water heater design, and he wasn't sure the correlation between water heater design and SIPs.
Well, the point I was trying to make is it's a holistic proposition where, we're focusing on a better building envelope, obviously, but what you're able to do at that point, since you are addressing the energy and the air movement aspects of things with a better, and of course the resilient aspect of it, but what you're trying to do is think about it holistically, through a right-sized HVAC system. As part of your design considerations, you need to think about water heat design, or water flow flow design for water efficiencies. But again, about 20% of the energy use in a building is for heating water. So it's important not to forget that aspect of it when we're talking about all the rest of it.
I think the big elephant in the room, which Larry and Steve both are asking about, I was going to ask about it myself, is the cost. The cost of a SIP system compared to 2 inches of spray foam skin with the balance being blown in fiberglass or cellulose. It's really difficult to talk about exact prices because every project is different. You have different geographical locations with different labor rates.
Yeah.
In a ballpark range, in some kind of ballpark sense, can you give us an idea of, you talked before about competitive pricing. When you compare SIPs to, I'll just call it conventional construction, or even comparing it to 2x6, what are you seeing with what you've done?
Well, cost is everything, of course, and you still have most clients that want, say a granite countertop is the first thing out of their mouth when you ask them what they want in their house. They say, okay, fine, here's your job cost breakdown, your construction budget. The first line item we're putting in there is for granite countertops, and then we're going to build the rest of the house and budget around that to make it as cost competitive as we can. But really, structural insulated panels have gotten very cost competitive with 2x6 framing and with the advanced insulation systems. And obviously, the wall assemblies, and again, talking about the entire envelope of the house, with the pressure that codes and regulations have put on them to perform better and better and better, has really driven the cost for a traditional stick frame, if you will, even with 2x6 construction, to just creep up. So now you're at the point where SIPs were already somewhat cost competitive. That makes them even more cost competitive. And again, if you look at this, we're in a union labor market, and we've got very, very good carpenter trades here. But the wages are higher, so time is definitely money for us. So if we're able to get that building up, put together and insulated in easily half the time, if not better, or a third the time of a stick front wall, well, that's money too, and that's usually part of the equation that doesn't get considered. Well, most people will look at a cost estimate for stick lumber and a cost estimate for SIPs. You may throw in insulation in that equation too, but then you don't talk about the time in the construction process. One cost impact that SIPs have is shipping. So you need to find where you're at in the country, where closest shipping. That's probably the cost difference maybe sometimes in what it takes to get material for the bottom line. But I know even those costs have improved recently over what it takes. And the nice thing is again, that building is insulated once it's up, so you don't have to have that trade come back in. If we do a standard subfloor, we may have them come in and foam the band boards or something like that, or have our insulator come in and foam some of the gaps or seal things up. But the cost is it's very effectively transferred with the use of SIPs panels.
Appreciate you sticking around a little bit longer, and also the attendees as well. Wanted to make sure that I got to the other questions that we have here. I think a big important one that maybe in a lot of people's minds, will these slides be available as a PDF later?
Yeah, I know, thanks to the folks at Green Builder Media, they are going to have these archived, and this whole presentation will be available. I don't know what format they'll be in, but obviously the main thing is going back through and getting the website information, sips.org, Green Builder Media website information, the appraisal information. That'll all be on there, and you can go to those websites and get most of the same information.
Okay. Yeah, and it sounds like these slides are going to be available through the SIPS.org website, and I know the recording of this webinar will be available through Green Builder Media probably by the end of this week. So we've got you covered there, Steve. I wanted to make sure I got to another question. How have you seen SIPS result in reduced maintenance for your clients?
Oh, it's huge. I mean, it's just a much more durable building system. So it's a huge has a huge impact on that. It's you know, the one of my concerns, obviously, because I guess you know, I just know about it, is the air and moisture intrusion into walls, and you know, trying to control those interior wall spaces. You know, the insulated area, if you're using fiberglass. You know, air will move through fiberglass if it's allowed to. Of course, it drags moisture with it if it's allowed to. You know, those are some of the concerns, and those are things that we're also trying to address now through the 2018 code cycle. And you can do that, but you have to be very forthright and dedicated and focused on properly putting those building envelopes with that cavity style construction together, where you just don't have that issue with structural insulated panels. That is a rigid, resilient panel that you don't have the issues. Obviously, since it's rigid and resilient, also helps you know, with the siding applications and the exterior, the entire exterior component of that building. Even on the inside, I mean, you know, we'll drywall the interior side of that structural insulated panel. Well, it's full of foam. It's not going to be able to poke a hole in it very easy. So even, you know, on the durability part of, you know, I referred to it earlier, is used by people on the inside. It's even more resilient. So yeah, we've had a lot of great feedback on that. And that's one of the items we focus on in building, is just a more durable building envelope that's part of the future maintenance of that building.
I had a quick question for you. You talked about right sizing earlier. What is your HVAC sub using? Are they using manual J or D or S or all three? Or
yeah, all three. All three. And you've got to do it. You know, there's a lot of unfortunately, it's changed quite a bit, especially with the last code cycle. But you know, there was a lot of rule of thumb type stuff going on, and systems weren't getting designed properly, and you'd have HVAC equipment that was oversized. You know, they were designed because they didn't want to get a phone call saying that, you know, my upstairs bedroom corner is too hot or too cold or whatever, so they might put a larger unit in to try to address that. But then you have those units short cycle, because again, they'll come on at high speed, they'll pressurize the house, get it up to temperature quickly, and then shut off. So you've got a lot of, and of course, you know, that's hard on the equipment, and the comfort level, you know, where you're heating that thing up with a forced air system. You know, it might heat up 5-7 degrees and then cool back down 5-7 degrees. You know, just because you can't find that equilibrium, where you have a better built building with the envelope, you put a right-sized piece of equipment in there with a variable speed fan, and that thing will run at a low speed, so it's less energy, keeps that house more comfortable. And you know, when you have periods of time where you may need more demand, it can spool up and go to a higher speed to satisfy that. If you have a lot of humidity load, say after taking showers in the morning, you know, it can spool up and help dry that house out a little bit better. But you know, good design and right sizing equipment is everything.
I see two more questions, and then we're gonna cut that off there.
Okay.
Just due to time. Steve's talking about SIPs as a roof panel.
Yeah.
He feels they're kind of a challenge in terms of cost efficiency or cost effectiveness there. I mean, I personally think they make a lot of sense in that application as well. Have you used them in a roof situation?
Yeah, we have done a lot of roofs. The photos of that home that I showed, that was the Vision home back in 2007. You could see that was a 1812 pitch roof on that house. That was difficult. We set those panels with a crane, and it was the design she wanted. So we, frankly, can do through a better, more easy to build design, can do a lot better job. Frankly, it's nice. You can use those. Now, in her case, their second floor, they had very little attic space up there, just the very top of that. Their second floor was took up quite a bit of that upper area. So those were not only a roof, but they were in essence kind of acted like walls too. In most applications, we'll design a lower pitch roof, but that allows us to have a smaller attic, but it's a conditioned attic. So it works very well. If we have a smaller design, we can actually run our ductwork above the ceiling because it's still in a conditioned space, and it really helps us out to make those things function and make the designs work. They're not difficult to build with, and I just like you said, Mike, it makes perfect sense to build the roof out of the same panels. It just, to me, it's all part of the envelope, and obviously the roof's an important part of that.
We're going to get to our last question here. I think it's a good one to wrap up on. What are the most noteworthy selling points to get builders to use SIPs?
I think the economics is everything. That's how we sell. We meet a new client, we explain to them why we do what we do. It's about making their monthly payment smaller for a better home that is going to last them. We them to understand that this is the biggest investment they're going to make, and they ought to think about it that way. If they were going to take, say it's a $300,000 home, they're going to take $300,000 and put it in the stock market for 15 or 30 years, which is the life of their mortgage, or even 5 to 8 years if they're going to resell the house. Say, they would want that investment to perform as good as it could. Well, why not with this biggest investment? And we want them to not only have an equitable position when they construct or remodel a house, but when when this thing is 8, 10, 20 years down the road, we want them to still have an equitable position with it. They're going to be, they put their house on the market in 10 years, and an agent's going to bring them to that house, to a potential buyer to that house to look at, and they're competing against 5 or 10 other homes at that price point in that neighborhood, and that's really when the rubber meets the road. If they can demonstrate what it costs to live in that house on a monthly basis compared to all the others, it's easy. What house would you buy? Well, obviously it's going to be that one. So that's where the payoff really happens, because they can maintain the value of that home and actually get a better value for it. So, and having the proper appraisers, getting the appraisals trained and having that process in place is huge to make that happen, obviously.
What about if you're trying to convince builders to switch?
Well, it's the same thing. Obviously, I've been a builder all my life. The biggest 4-letter word in our industry is change, and we're all stubborn. But again, when you show the stats, and matter of fact, NHB is about to publish an updated version of those McGraw-Hill Construction, which is now Dodge Construction. They've changed their name, but they do that market survey every couple of years, and they're about to release, I think probably at IBS, International Builder Show, next month, they'll release the latest market study, and they just have shown since 2007, I think, when they did the first one, the growth of this type of construction, and the market for this kind of construction has grown exponentially. And I think especially coming out of the economic downturn, when you had so many people, literally trapped in their home because they couldn't sell it because of the short sales down the street, and they got kicked in the shins every month in the form of their utility bill. They're wanting to get out and look at a better method of doing this. So we can get builders, and not just builders, but all the people as a builder, all the people that support me, my suppliers, my trades, realtors, design professionals, get everybody on more of the same page. I think it's going to help the business aspects of it, and that's how we have to approach it too, is from a business standpoint. That's what we do with the University of Missouri. We don't come at it from a environmental or a social focus like a lot of times it may come out of the university. We're coming out of our small business and technology development center. You can see the logo at the bottom of the slide that's still up. We're coming at it from a pure business standpoint to educate businesses on how to take advantage of this market.
All right. Well, I want to wrap up there. Thank Matt for sharing his time with us today, and certainly all the attendees and all their questions. It made for a really, really great webinar.
Thank you all, and thanks again to Green Builder Media for doing this. They had a long time friendship and relationship with them, and they're awesome. And of course, SEPA, all the folks there, Jack and all the staff that support this sort of thing. It's a great organization, and I'm proud to be a part of it.
Well, I don't have another webinar to promote today, so I just want to wish everyone a happy holiday season and a happy new year, and we will talk to you again in 2016.